Hello everyone, greetings of the day. I am Charan, pursuing my second BTech in the stream of Computer Science Engineering, Artificial Intelligence and Machine Learning at Prasad V. Potluri, Siddhartha Institute of Technology. Today, I am here to discuss about the topic, the types of machine learning. First, we will know the definition of machine learning. A computer program is said to learn from experience E with respect to some class of tasks T and performance measure P if its performance at tasks in T as measured by P improves with experience E. There are three types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. We will go in detail about each form. First one would be supervised learning. Here, the model learns from labeled data with set of input-output pairs. The goal is to predict the output or a new class label based on the input given, and the model gets trained from a previous inputs. Example, predicting house prices. The learning process is as follows. The model is trained on a data set of labeled examples. That is, first the model is trained based on some set of inputs and outputs, and it learns to identify patterns and relationships between the inputs and outputs. Once trained, it can predict the outputs for new inputs. So, for example, if we see iris data set, we have 150 instances and 4 features where based on this, the iris plant is categorized based on Iris versicolor, Iris setosa, or Iris virginica. So if we give a new input based on the trained model, it takes from the old inputs and gives a new output. So the in this way, the supervised learning works. We have two types of supervised learning again. They are classification models and regression models. Classification models, it is a type of supervised learning that aims to predict a categorical label for each input. That is, it have a fixed number of distinct values and it is used for categorizing the outputs. So, for example, if we see we have emails, we get sometimes spam emails. So we can categorize based on the emails as spam emails or normal emails. And another one can be an input is a fruit and the output is a label indicating the type of fruit, whether it can be a mango or an apple. So the regression models. The second one would be regression models. Regression is the type of supervised learning where the goal is to predict a continuous output variable. That is, it have infinity number of distinct variables, such as, for example, if we see prediction of house prices, the house prices continuously vary based on day-to-day evaluation. And the stock prices also continuously vary. And in the same way, the temperature of a given location also varies. Next, we will see the applications of supervised learning. The supervised learning has very distinct applications like spam filtering. As we have seen earlier, we can filter based on normal emails as well as spam emails. The next one will be disease prediction. Based on the given data from the patient, it can categorize the disease and give an output that is the resultant disease. And autonomous vehicles. Self-driving cars use supervised learning to identify obstacles. That is, they take the obstacles as input data and the action to be taken as output data. Computer vision. Deep learning models can analyze visual information like images and videos to classify objects. That is, deep learning models takes input as videos and images and they classify based on the inputs. And now the next type would be unsupervised learning. Here in this unsupervised learning, the model learns from unlabeled data. That is, the model is given only set of inputs and no set of inputs and outputs are given. That is, it identifies the patterns and structures without explicit guidance. That is, the user does not give any inputs and set of outputs previously. It aims to discover insights and relationships hidden in the data. The learning process. The model explores the data to find patterns, trends, and relationships without any predefined labels. Means the model evaluates the outputs based on the inputs given without any previous set of inputs outputs as a data set. This helps in understanding the underlying structure of the data. Means the model always helps to find the relationship or structures between the inputs and outputs. Next, there are three types of unsupervised learning. They are clustering, association, rule mining, and dimensionality reduction. Clustering. Clustering means grouping similar data points into clusters based on their characteristics. That is, we group similar objects into several groups and categorize them. This is known as clustering. The next one is association rule mining. Discovering relationships between items in a data set. For example, Identifying patterns of items frequently brought together. That is, we identify the relationship between the user and the user's interface and take out the patterns for future enhancement. The next one would be dimensionality reduction, simplifying complex data by reducing the number of variables or features while preserving as much information as possible. That is, we simplify the complex data that is visible for the user into number of variables or features, and we reduce the data such that it is in a simpler way to understand while preserving the important information. The applications of unsupervised learning would be customer segmentation, grouping customers based on their behavior and preferences to personalize marketing strategies. Here, as we have seen earlier in the clustering, this is how basically clustering works. Clustering observes the user's behavior, whether he is going to a link frequently, and the model matches the frequency of the user going to visiting the website frequently, and it preferences to personalize those frequently visited websites and segments into different types of different types of groups. The next one would be anomaly detection. The customer segmentation also comes under clustering, as we have seen. Anomaly detection, identifying unusual patterns or outliers in data to detect fraudulent transactions, system failures, or anomalies. This is basically comes under association rule mining. Here, we identify the patterns that are frequently occurring and we outlay the data to detect fraudulent transactions, that is spam transactions or any system failures, or we can also take anomalies. Next, image compression, reducing the size of images while preserving important visual information. Here, the image is compressed into a reduced size. That is, we compress them into a small size image version, but we do not hide any irrelevant, but we do not hide any important information, and we preserve the important visual information. Now, the third type would be reinforcement learning. Reinforcement learning basically have some terms that has to be understood before understanding the reinforcement learning actual topic. Those are agent. The agent is nothing but a learner or decision maker. Environment. Everything the agent interacts with is called as an environment. Policy. The strategy used by the agent to choose actions is called as a policy. It can also be called as an action taken. Reward signal. The feedback that is given for the actions that are taken by the agent in the environment is called as a reward signal. Now, here in the reinforcement learning, it involves an agent that learns to make decisions by interacting with the environment. The agent receives rewards or penalties based on the actions that are taken, and the goal of the reinforcement learning is to maximize the cumulative record. That is, the cumulative record can also be set as the final maximization of the reward. It should be greater than the penalty. We have to learn few terms which I have said earlier. Those are agent, environment, policy, and reward signal. Now, the next one would be the learning process of reinforcement learning. First one would be the initialization. Initialization is a process where the agent first evaluates the initial state and starts at an initial state. The next one would be action selection. Action selection is a process where the agent selects an action based on its current state and policy, where which the agent have observed in the initial state, and he observes how the environment behaves. The next one is state transition. The environment transitions to a new state as a result of agent's action. That is, the environment transitions to a new state. That is, we get or evolve a new state that is taken as a result of the action that is taken by the agent. The next one would be reward. The agent receives a reward or penalty from the environment based on the transition. Based on the transition the agent has taken, the agent receives a reward or penalty. The reward means the agent has done a benefit to the user, or the penalty means the agent is not working properly. The last one would be learning. The agent updates its policy using the reward signal to improve future decisions. That is, the agent updates the policies that are taken in the earlier, whether it has to be improved for better rewards and reduce the penalties, or continues the same as the rewards. So it improves the future decisions and also the accuracy. The next one would be the applications of reinforcement learning. Applications of reinforcement learning, they have been in various forms, like in gameplay. In gameplay, for example, if a human learns how to ride a bicycle, it does not come under supervised or unsupervised learning. It comes under reinforcement learning. That is, we only learn how to ride a bicycle even after many failures, such that in such a way the also game playing. In game playing, the agent sticks to the environment and acts according to the environment. Like in the chess, the agent has to act with respect to the environment that is changing spontaneously time to time based on the opponent. The next one would be robotics. Robots can learn to perform tasks in dynamic environments such as navigating, manipulating objects, and interacting with human beings. That is, the robots have to learn how to act in the environment based on the other people's feelings. That is, the robot has also have to have feelings. The agent should also have feelings that must be able to make the opposite person accept it and accepts its answers and manipulate other person time to time, interact in a very humble way and a very how can you say, a very accurate, precise way to the human being. The next one would be financial trading. Algorithms can learn to make optimal trading decisions based on market data and historical trends. That is, the in reinforcement learning, the algorithms that are taken in reinforcement learning helps to optimal trading decisions to get a maximum profit based on the market data and historical trends. That is, based on the historical trends, we can get the historical trends where we can get the stock prices, those are downfall or the stock prices are increasing. And based on this historical data, we can predict whether the stock price will be increased or decreased, and the shares will have the more value or they will not have any value. So in this way, we can apply reinforcement learning. And not only this, reinforcement learning is also involved in many sectors. Thank you for listening to me.